Okay, so we're doing problems involving two right triangles. Right now, we could have right angles that we have to deal with, so we'd be using SOHCAHTOA. Later in the note, we might end up having sine law or cosine law show up. We want you to use the most efficient way possible. So let's take a look at the first one. It says solve for each unknown. So in this case, we have to find x and y. So if you look, if I circled the 27 degrees, I wouldn't have enough to go and find y, but once I find x, I would, because I would then have adjacent and hypotenuse, and I could go and do my cosine. So let's start with 38 degrees. A lot of times in these questions, when you have two, in this case we actually have three triangles, if you count the big one here, you will be using one piece of information from one of the triangles so that you have enough information in the other triangle to solve for your last unknown. So go and circle your 38 degrees. If you look, x and 10, that will be adjacent and hypotenuse, so that's why I'm going to do the cos of 38 equals x over 10. Since I'm dividing by 10, this will come to the other side and be multiplied. Punch this on your calculator, and I end up getting 7.9 when I round it. So the reason I took all these extra decimals here before I rounded it, I have to round to one decimal place because they asked me to find it, and we round side lengths to one decimal place. But if you look over here, I'm going to be using my x value in my next calculation, so I want it to be a little more accurate than one decimal place when I go and do that next calculation. So I need to write down all these extra decimals so that I can include them when I go and calculate this one so that the final answer will be more accurate. So let's take a look at the next one. We go and circle 27 degrees. And if we look, we're dealing with x, which we already found out, and the y, so this is adjacent, and this is hypotenuse. So adjacent over hypotenuse, that's why we're doing cos of 27. And then this y will come to the other side. Since it was divided on this side, it'll be multiplied here. Then the cos of 27 degrees will come and divide. I have lots of people that say, can we skip that middle step and go straight to it? And if you're comfortable with it, yes, you can. And then if we look here, we do 8.8 and we round it to one decimal place. Since I'm not using that in any future calculation, I can round right to one decimal place right away. It looks here that I forgot my units, so don't forget to put in meters. Next question. Okay, getting a little more complicated on this one. I've labeled some extra pieces in here to help me out. They want me to go and find out what h is. Now they labeled h because it's the height of the triangle, not because it's the hypotenuse, so don't get confused with that. And we actually have three triangles here. We have one small one, we have one large one, and we have one medium one right here. And again, I'm going to probably need some piece of information from one of the three triangles to help me find the h in this little triangle over here. So if you look, if I look here, I have h. I don't know what that length is. I don't know what that length is. And I have an angle. So that's not enough information to help me find x. If I look at this large one here, I have this triangle right here. Well, I have a side and an opposite angle, and I have an angle and an unknown. So that's enough information to do the sine law. So let's go and do it. I get 200 over the sine of the opposite angle, which was 80 degrees. You'll see I saw the 60, I saw the 40, so I immediately calculated the 80 degrees by doing 180 minus the 60 minus the 40. So 200 over sine of 80 equals x over the sine of the opposite angle. And then the sine of 60 degrees comes up and multiplies, and I get my answer there. Again, they didn't ask me to find x, but I had to find x to be able to find h. So I took extra decimal places because I'm going to have to use this in a future calculation. And then I'm going to try and find h now, so I circle this angle, and I have enough information in this right triangle right here to find out what h is. So I circle this, I have opposite and hypotenuse, so I'm going to do sine of 40 is opposite over hypotenuse. This will come over to the other side and multiply, and I end up getting 113.1, and I just put my meters in there. You don't need a formal therefore statement in these because they're not word problems. Next question. Okay, you can see that I've added a few extra things right away here. This is 40, so this must be 140. If you look right in this triangle right here, they're going to add to 180. So I do 180 minus 40 minus 90 gave me 50. And if you look, I have 25 and 140, so when I subtract those from 180, I end up getting the 15 degrees right there. I'm going to have to work with some of these triangles. There's 3 there. There's 2 right triangles right here and right here. And then there's this obtuse triangle right here. So I'm going to be looking for W, which is part of the large triangle. So I'm guessing I'm not going to have enough to do that, which I don't. I have this big angle here would be 65. I've got 25. And I've got W. So I need another side in this large triangle, so that's why I labeled the X here. So let's go and find that. Well, I don't have enough information in the large triangle to find X, so I'm going to use this obtuse triangle. If you look, I know an angle and the opposite side, and an angle and one more side that I need to look for there, so that's perfect for sine law. So I'm going to end up doing X over sine of 140 equals 50 over sine of 15. And I'm going to take the 140, sine of 140 to the other side, it'll be multiplied. And again, I take those extra decimals because I'm going to need those in future calculations. And then I go, and if I circle my 25 degrees right here, I'm going to do adjacent for the large right triangle over hypotenuse. So that's going to be cosine. So I get cosine of 25 degrees equals my adjacent, which was W, over what I had found for X, the 124.1770306. That comes over and multiplies with this whole thing, and I end up getting 112.5 meters. And then that's my final answer. I round to 1 decimal place. These questions take a lot of practice to be able to see what you need to do and in what order. So when you look at these, there's 3 triangles that you can work with, and you need to figure out what's my last one. Well, your last one's probably the one that has your unknown, so that's going to be W in this case. So that's the large right triangle. And then you're probably going to be working with this right triangle or this obtuse triangle. And it's just looking at each of them and figuring out which one has enough information to give you a piece of that final triangle you're going to be working with. So if you look, this X right here was part of both triangles, this obtuse one and this large right angle one. So that's why I found it. It's going to share a common piece between the 2 that you're working with. That covers it for this evening. Again, your homework's at the bottom of the page. You'll do that tomorrow in class. Hope you guys have a good night.